Hello, I'm DevPoodle. Today I'll be showing you how to create a 3D pixel art effect in Godot 4. Let's go up to the top left here and go into Project Settings. At the top right, we want to click Advanced Settings because it's just going to give us more access to settings. Under Display, we want to go into Window, and we want to change the viewport width and height. Let's change it to something more normal, like 1280 for width and 720 for height. Let's scroll down. We want to press this always on top. This is going to be useful for debugging because it means that the window we're running the game in is always going to be over the engine window, so we can always see what's happening in it and click on it. Let's scroll down. Under stretch mode, we want to click viewport. This stretch mode just works way better in pixel art style games, which is the look we're going for. Let's scroll down further into settings. We want to go to rendering. First thing is textures. We want to change default texture filter to nearest. This filter essentially makes our textures interpreted as being pixel art rather than being regular 2D art. So that's what we want to click for that. I'm going to scroll down even further to shading. We want to click both of these overrides. Both of these overrides make the rendering slightly worse, but in the case of trying to make a pixel art effect, it actually ends up improving the look we're going for. I'm going to scroll down even further to anti-aliasing. This is the final thing we're changing. We want to turn off anti-aliasing. If you have any of these enabled, you definitely want to turn them off. They ruin the effect quite a lot. Alright, now we can close project settings. So now I'm just going to create a basic example scene. So let's just create a new scene called example. It's going to be a 3D scene. The first thing we want to do is add a sun and environment to it. So let's just get these. I'm going to change the ground color here to pure black. It will work better with the effect, as you'll see in a moment. Let's add the sun to the scene. Go up here, let's add environment to scene. So now our default scene is set up. Now we'll just add in a simple cube so we can see what the effect actually looks like on an object. So mesh instance 3D, and then add a default box mesh. Now we need to create an object to actually render the post-processing effect, so let's add file node. We're going to also add a mesh instance, but this time it's going to be a 2D mesh instance. At the top right here, under mesh, we want to add in a basic quad mesh. This is going to render over our entire screen, so it has to be the same resolution, 1280 by 720. And then we also have to offset it a little bit, so we offset the x value by half of the width, 640, and then y value by half of the height, which would be 360. So now, as you can see, it covers up the entire area of where the camera would be. We want to scroll down, change texture to nearest. This might actually be redundant, but just in case, I'm going to change it to nearest. And then we're going to go to material, create a new shader material, which is going to be our post-processing shader, and then a new shader. So let's just call this pixelart.gd shader. So in this shader, the first thing we want to do is specify some render modes. These are essentially things that tell Godot how to interpret our shader and how to convert it to a real shader that the GPU actually runs. So we're going to do skip vertex transform because we don't want this quad to move around at all, so it doesn't need to have vertex transformation. And we also want it to be unshaded because we don't want this quad to be shaded either. Now we are only going to be using the fragment function of the shader, so we can delete all the other stuff that it came with by default. We want to add in a new uniform for the screen texture. So uniform sampler 2D, we'll call it screen texture, and then colon hint screen texture, semicolon. Now just to make sure everything's working, we're going to replace the content of the fragment shader with color equals texture, and then the screen texture, and then the screen UV, and then I believe that should be it actually. We put a semicolon, this should be invisible. What's happening is that it's sampling what's under it, so it effectively looks invisible, but is actually there. So the first thing to creating our pixel art effect is to downscale it. Basically, we want it to be a lower resolution than this. And ideally, it should be able to change kind of dynamically, which is why we're doing it in the shader, rather than just setting the resolution of the whole window. It also means that we can have stuff that isn't affected by the post-processing. So for example, UI doesn't have to be pixelated. So let's add a constant that says what our target resolution is going to be. I'll just call it target. Actually, no, let's call it target resolution. And it's going to be a vec2. So in our case, I'm going to have 320 by 180. This is a 16 by 9 resolution that's kind of common on like older video game consoles, so that's what we're going with. So let's create an independent UV variable, so let's just call it UV. What this is going to be, it's going to be the UV we're using before, the screen UV, multiplied by the target resolution. Then what we're going to do is we're going to wrap this whole thing around in parentheses, and we're going to floor it. Then at the end here, we're going to divide by target resolution. And then finally, we'll replace screen UV with UV. Now, if we run this, let's select current. As you can see, we can't see anything. That's because we don't have a 3D camera. What I'm going to do is I'm going to switch in this 3D tab, and we could just create a 3D camera, but instead I'm going to use this debugging feature called Project Camera Override. We click this, and now it means we can effectively move the camera around in the editor, and then it moves it in the game as well. This is just a good way of testing the camera because, you know, we don't want to have to go through the work of actually setting up a camera right now. So as you can see, this does effectively downsample, but there's one important thing we're missing, which, as you can see, the edges of these are anti-aliased. We really don't want this if we want to go for like a pixel perfect sort of effect. So we're going to have to change our shader. Here, with hint screen texture, we also want to add another hint called filter nearest. I believe I already mentioned that this is effectively the pixel art filter for textures, so it's going to help us get the look we want. We can now rerun this. And as you can see, we don't have that anti-aliasing anymore. We have some weird artifacts in the background. Those should go away with another effect we're going to add soon. So the next effect we are going to add is color quantization. Effectively what this does is it reduces the amount of colors that can be rendered onto the screen. This is an absolutely vital part of getting that like pixel art look, and it's incredibly common for older consoles to have a palette limit like this. So the first thing we want to do is we want to add another constant that's just going to be a float this time, and we'll call it colors per channel. Effectively what this does is it gives us the amount of values that we can have in the red channel, green channel, and blue channel. So for example, if this is 8, then there's 8 possible values for red, 8 possible values for blue, 8 possible values for green, and then you can mix all 3 of those 8 values to get like 8 times 8 times 8, which is some number that I don't want to calculate right now. So as you can see, it goes up pretty high because it's technically cubed, the amount of colors we have total, which is why I'm setting it to something really low, like 8. So next we're going to, just like we created an independent UV variable, we're going to create an independent color variable. Let's make this a vec3, we'll just call it color. So let's copy and paste this. Then we'll create another variable called quantized color, which is going to be the color after we've limited the amount of colors per channel. So this is going to be incredibly similar to how we handled UV. In fact, let's just copy and paste it. But instead of screen UV, we're going to use color. And instead of target resolution, we're going to use colors per channel. And the final thing is, here we need to do .rgb. Okay, that works. Now we just need to replace this color with quantized color. First we have to create a vec4. We put in quantized color and then 1, because we want to have 1 in the alpha channel. So now if we run this, this should have a quantized color. It should be fairly obvious. Let's click that little camera icon. And as you can see, yes, it's very obvious. If we look at the sky, there's very clear bands of color because we've prevented it from rendering any colors that are in between that. So as you can see, this is very nice for that sort of like pixel art effect. You even get some natural sort of like dithering on some areas of the sky. If we look at the sun, it looks kind of weird. This is where you might want to change the skybox and stuff like that. If you change it to a proper like image skybox, it might look a little bit less strange. But as you can see, this is our effect basically completed, right? There was just a couple project settings we have to change and this very simple shader, and we got a pretty convincing like 3D pixel art sort of effect. The major thing I'd want to add to this eventually is outlines, and I may do a video on pixel perfect outlines eventually because that's also very interesting. But for now, I think this is a pretty decent effect. So thank you for watching. I hope you learned something from this, and goodbye!